When it comes to software engineering interviews, one of the most crucial rounds is the low-level design, often referred to as LLD. While high-level design focuses on architecture, system boundaries, and overall structure, low-level design digs deeper into the implementation details. It examines how classes, objects, relationships, and methods will work together to solve real problems. For many candidates, the low-level design round can feel intimidating because it combines both theoretical knowledge of design principles and practical application through coding. Interviewers want to test not only your coding ability but also your thought process, your ability to model real-world problems, and your understanding of principles like solid, design patterns, and scalability at a micro level. That's why preparing for low-level design interview questions is essential. In this video, we'll cover the most common questions you might face, give structured sample answers, and share practical tips to help you perform well. Question 1. What is low-level design, and why is it important? Here's the answer. Low-level design, or LLD, focuses on the internal details of a system. It defines how different modules, classes, and methods interact to fulfill specific requirements. While high-level design provides the big picture, low-level design ensures the system is practical, maintainable, and scalable at the code level. It is important because it reduces ambiguity, makes implementation easier, and ensures that the solution adheres to good coding practices and design principles. Tip: keep your explanation simple but structured. Use an example if asked, like designing a library management system or ride-sharing app. Question 2. How do you approach solving a low-level design problem in an interview? Here's the answer. My approach usually starts with clarifying requirements. I ask questions to remove ambiguity and confirm assumptions. Next, I identify the core entities or classes needed, then define their attributes and methods. I check how these entities will interact with one another, making use of design principles like solid and object-oriented programming. Finally, I consider edge cases, extensibility, and potential use of design patterns to make the system cleaner. Tip: always verbalize your thought process. Interviewers want to see how you think, not just the final diagram or code. Question 3. Can you explain the SOLID principles? Here's the answer. Yes, SOLID is an acronym for 5 important design principles. S. Single responsibility principle. A class should have only one reason to change. O. Open, closed principle. Software entities should be open for extension but closed for modification. L. Liskov substitution principle. Objects of a superclass should be replaceable with objects of subclasses without breaking functionality. I. Interface segregation principle. No client should be forced to depend on methods it does not use. D. Dependency inversion principle. High-level modules should not depend on low-level modules. Both should depend on abstractions. These principles make code cleaner, easier to maintain, and less prone to errors. Tip: if asked in detail, give a simple example for each principle. Question 4. Design a parking lot system. This is one of the most classic LLD interview questions. Here's the answer. To design a parking lot system, I would start by identifying the core entities: parking lot, parking floor, parking spot, vehicle, ticket, and payment. Parking lot would have multiple floors, each floor would have multiple spots, and each spot can be occupied by a vehicle. Vehicles could be of different types like car, bike, or truck. When a vehicle enters, a ticket is issued with the details, and when it leaves, payment is processed. I would also define enums for vehicle type and spot type, and services for assigning spots and managing tickets. Tip: break down the problem step by step. Don't rush to code immediately, focus on the design. Question 5. What are some commonly used design patterns in low-level design? Here's the answer. Some common design patterns include singleton, factory, strategy, observer, and builder. For example, singleton ensures only one instance of a class, which is useful for managing shared resources like logging. Factory helps create objects without exposing the creation logic, useful when dealing with multiple subclasses. Strategy allows selecting an algorithm at runtime, while observer is useful when multiple objects need to be updated when one changes. Builder is often used for constructing complex objects step by step. Tip: be ready to give real-world examples for at least 2 patterns. Question 6. How would you design an online cab booking system? Here's the answer. In an online cab booking system, the main entities would be rider, driver, cab, trip, and payment. The rider can request a cab, and the system matches them with an available driver. A trip entity records details such as start location, end location, fare, and status. A cab object would be linked to a driver. The system would also require services for ride matching, fare calculation, and payment. For scalability, I would separate out modules such as trip management service, driver service, and payment service. Tip: think in terms of modular components and relationships. That shows clarity of thought. Question 7. How do you ensure scalability and flexibility in your designs? Here's the answer. I ensure scalability by designing systems that are modular and loosely coupled. I apply design patterns where needed, use interfaces for flexibility, and keep my classes focused on single responsibilities. For example, instead of hard-coding dependencies, I use dependency injection so that components can be easily replaced or extended. This approach makes the system future-proof and easier to maintain. Tip: use buzzwords like modularity, loose coupling, and extensibility, but always back them with an example. Question 8. How do you handle edge cases in low-level design? Here's the answer. Handling edge cases starts with asking the right questions. For example, in a library management system, what if 2 users try to reserve the same book at the same time? To handle this, I would use locking or concurrency control mechanisms. I also validate inputs, check for null values, and ensure proper exception handling. By considering these cases up front, I can design systems that are robust and reliable. Tip: showing awareness of edge cases makes you look practical and experienced. Question 9. Can you walk me through designing a notification system? Here's the answer. A notification system needs to support multiple channels like email, SMS, and push notifications. I would create an abstract notification class with methods like send. Then, I would create subclasses like email notification, SMS notification, and push notification. To allow flexibility, I would use the strategy pattern so that the notification type can be selected at runtime. A notification service would manage sending notifications to users. This design allows easy addition of new channels in the future. Tip: stress extensibility. Interviewers love when your design can handle future needs. Question 10. What tips would you give to someone preparing for LLD interviews? Here's the answer. My advice would be to practice designing common systems like parking lots, elevators, online food delivery apps, or hotel booking systems. Focus on identifying entities, relationships, and behaviors. Revise core object-oriented concepts, design patterns, and solid principles. During the interview, speak clearly, explain your thought process, and use examples to make your design practical. Don't overcomplicate things. Simplicity and clarity usually win. Tip: practice drawing UML diagrams or class diagrams. It helps communicate your design visually. Closing thoughts. Low-level design interviews can feel challenging, but they are also an opportunity to showcase your problem-solving skills and coding mindset. Interviewers are less interested in perfection and more interested in your structured thinking, clarity, and ability to handle complexity. The best way to prepare is to practice regularly with real-world examples, study design patterns, and improve your understanding of object-oriented design. Remember that good low-level design is not just about classes and methods, it's about creating systems that are easy to extend, maintain, and use. With consistent practice and a calm, confident approach, you can master low-level design interview questions and impress your interviewers.